This is day 1, week 1, and I'm going to talk about scaling networks. Took the pretest, and the pretest is open until Friday midnight. So if you weren't able to take it in class, then you can take it on your own, preferably before Thursday. But it's available on Friday, and the multiple takes if you want to take it again. So we talked about the OSI model. We talked about the TCP IP model. We reviewed that. Talked about design layers and a little bit of the course information. The course functions similar to previous networking courses, NET-1 and NET-2. So, the students tried to list the layers from memory, and so we started here. We talked about the physical layer, medium, we're going to send it across, how we're going to send the bits across some medium fiber, wire, wireless through the air. And this is not all the options, but the two main options we talked about: 4G, 5G, Wi-Fi. I'm going to move so I can see. We talked a lot about network access. The course, first half of the course deals with a lot of data link, physical connections, access to the network. The TCP IP model calls this network access right in here. And it really is. The data link layer with switches, access points, and so forth. How do we access the network? Network layer, talk about addressing and the best path, routes. In the TCP IP model, it's called the internet. Transport layer is transport. How are we going to transport? Are we going to make sure it gets there, or are we just going to send it? And there's a lot to the transport layer. And then the next three: how are we going to present the data, linked into some app, and setting up a session for TCP IP. Over here it's just called the application layer. So we reviewed these concepts and talked about them in class. So when you think about your data, you have an application, the data gets presented, maybe encrypted or whatever. You set up a session with your peering place on the other side. How are you going to transport the data? How is it going to get routed? And the data link and physical layers, the data link is how you're going to get it back to the device. And then it's going to take those stream of bits and put them on the medium. And then when it gets to the other end, this might seem redundant for you, but so it goes, and when it comes up the other end, the medium takes the bits, the data link, make sure right device, network, match that up, right device, session, presentation, ends up back at the app, or an app, depending on where you're going. Got a couple pages left here. So here we talked a little bit about the current configuration, and that'll adjust during the term. It'll be kind of a fun term to see the transition to how we're going to run it. We got our main Nexus switch here, and how that's going to communicate in our rack with our virtuals and our Nimble storage, and then how we're going to connect that to the internet, and from there back to the classrooms and so forth. a little bit different than what we currently have. Currently we have a couple switches inside each classroom. One of the switch functions on a DMZ, we call it, in which they have direct access through the firewall out. And the other switch communicates with our servers. So these are good for doing labs and so forth. In the classroom you can get internet access, but you're not crossing over with our server farm, which currently would be this setup. And then we have the main campus cloud here. We talked about reviewing network address translation. We're going to do some work on Thursday. We'll do some lab work, mostly review. And we started out, we talked about access through a switch connected to a multi-layer switch or distribution layer, go through some firewall, maybe to a router on the edge, and goes out to the internet. Here maybe we have two ISPs we're connected to, two separate ones. So if one ISP is having problems, we can go through the other. So then we just repeat this process, and then we, I'll use a different color here, we can have redundancy in our network. So if we have issues here, this traffic can go this way. And I talked about this idea of a virtual default gateway and MAC address. So that would go into the devices, and then the networking would decide which way the devices would go. In fact, it could even split the traffic. This is a big part of the first half of the course. We'll talk about when you hook switches together like this, where traffic could literally go on a loop. So we have to account for that. Spanning tree protocol helps us do that. We can do some configurations here. You can do a lot, but we're only going to look at the bare necessary things for that. I talked a little bit about power over Ethernet. In network design, we do a lot around looking at 3 different design layers. How do we get access in? Well, our phones either connect to a tower, or maybe they connect to an access point, our computing devices to a switch, or they could connect to any of these 3. But we have some connection into the network. And we talked about endpoint devices. And the security is a big area here. Then the distribution layer right here figures out how to distribute this data. Is it going to some type of services, like a web server, internal web server, an internal data storage, maybe you got a huge amount of data storage, and so forth. Your authentication, authorization servers, the whole bit. So we can have multi-layered switches, and then later on we talk about, we'll start building within here, some type of redundancy in our network. Then we can have a core layer made up primarily of routers that's going to move traffic to the core. So we gave an example. Maybe this is some relatively big company and they pay a service provider to make these connections. And then they have a plant here, maybe a plant here, and a plant here, and these all talk to each other. One protocol is MPLS, it's multi-protocol label switching, something like that. I'd have to look it up exactly. But so here, and this is the second half of the course, we talk about routing protocols. So if this link goes down, now can this traffic go this way? And routing protocols will take care of that. And think about it, the internet wouldn't work without some type of routing protocol to make that work. Alright, so we'll do a lab on Thursday and wrap up the chapter. Got a bunch of terms, we got to verify that we're on track with those. Well, that's it.